Spacewalks, also known as extravehicular activities or EVAs, are crucial for maintaining and repairing spacecraft, deploying satellites and conducting scientific research. These intricate operations take astronauts outside the safety of their spacecraft and expose them to the unforgiving environment of space. In this perilous realm, where gravity is absent and the vacuum of space poses constant threats, astronauts rely on a simple yet indispensable tool: tethers. Tethers are lifelines that connect astronauts to their spacecraft, providing a physical link to safety and preventing them from drifting off into the abyss. Spacewalks are complex and dangerous undertakings requiring meticulous planning, specialized equipment, and highly trained astronauts. Every movement must be carefully choreographed and executed, as even a small mistake can have dire consequences. Tethers play a vital role in ensuring the safety of astronauts during EVAs by providing a constant connection to the spacecraft. These strong, flexible cables are designed to withstand the harsh conditions of space, including extreme temperatures, radiation, and micrometeoroids. The importance of tethers was recognized from the very beginning of human space exploration. During the early days of the space race, engineers and scientists quickly realized that astronauts venturing outside their spacecraft would need a way to stay connected and prevent themselves from floating away. This realization led to the development of specialized tethers that have become an integral part of all spacewalks. Today, tethers are an indispensable tool for astronauts conducting EVAs, providing a vital link to safety and enabling them to perform their tasks with confidence. As we continue to explore the cosmos and push the boundaries of human ingenuity, tethers will remain an essential part of space exploration, ensuring the well-being of astronauts as they venture further into the unknown. On March 18, 1965, Soviet cosmonaut Alexei Leonov made history by becoming the first human to perform a spacewalk. His daring feat, a testament to human courage and ingenuity, captivated the world and marked a pivotal moment in the history of space exploration. However, Leonov's groundbreaking spacewalk was not without its challenges, highlighting the inherent risks and complexities of venturing outside the confines of a spacecraft. Leonov's mission, Voskhod 2, was tasked with demonstrating the feasibility of human spacewalks and gathering valuable data about the effects of the space environment on the human body. Equipped with a specially designed spacesuit and a tether connecting him to the spacecraft, Leonov exited the Voskhod 2 capsule and floated freely in the vacuum of space for the first time. The world watched in awe as Leonov, tethered to his spacecraft, drifted against the backdrop of the Earth, demonstrating the remarkable capabilities of human exploration. However, Leonov's historic spacewalk soon encountered unforeseen difficulties. His suit, designed to operate in the vacuum of space, unexpectedly inflated, making movement difficult and hindering his ability to re-enter the airlock. The unexpected inflation of his suit made it difficult for Leonov to maneuver and operate the hatch. This unforeseen complication forced Leonov to vent some of his suit's pressure, a risky maneuver that could have resulted in decompression sickness. Leonov's experience during the first spacewalk underscored the importance of tethers as lifelines in the unforgiving environment of space. His tether provided a crucial link to the spacecraft, preventing him from drifting away while he struggled with his suit. The Voskhod 2 mission, though not without its challenges, paved the way for future spacewalks and demonstrated the importance of meticulous planning, rigorous training, and robust safety measures for extravehicular activities. The vast expanse of space, while awe-inspiring, poses significant dangers to astronauts who venture outside their spacecraft. The absence of gravity, extreme temperatures, and potential exposure to micrometeoroids and radiation create a hazardous environment. Among the most significant risks is becoming untethered, a scenario that could leave them stranded, drifting away with no way to return. An untethered astronaut would experience Newton's first law, remaining in motion unless acted upon by an external force. Without a tether, even a slight push could send an astronaut tumbling uncontrollably into the abyss. Their momentum would keep them moving away, and without propulsion or a tether, their fate would be sealed. The consequences of becoming untethered are dire. Spacesuits provide life support but have a limited supply of oxygen. Once that supply is exhausted, the astronaut would suffocate. Extreme temperatures would eventually take their toll, leading to hypothermia or hyperthermia. The thought of being untethered is harrowing, conjuring images of a solitary figure adrift succumbing to the conditions. It is a testament to meticulous planning, rigorous training, and stringent safety protocols that such a scenario has never come to pass. Tethers play a crucial role in preventing such tragedies, ensuring astronauts always have a physical connection to their spacecraft. Section 4. A guiding hand, how tethers keep astronauts on course. In the microgravity environment of space, movement takes on a whole new dimension. Astronauts freed from the constraints of Earth's gravity can effortlessly glide through the void, but this newfound freedom comes at a price. Without the familiar pull of gravity to anchor them, even the slightest push can send them drifting off course, making precise movement and navigation a constant challenge. This is where tethers come into play, acting as guiding hands that help astronauts maintain their bearings and execute their tasks with precision. Tethers, those sturdy yet flexible cables connecting astronauts to their spacecraft, serve as lifelines in the truest sense of the word. But beyond their primary function of preventing astronauts from floating away, tethers also play a vital role in facilitating movement and ensuring accurate positioning during extravehicular activities. By attaching themselves to various points on the exterior of the spacecraft or on specialized handrails, astronauts can use tethers to control their momentum and navigate the exterior of their spacecraft with relative ease. Imagine an astronaut tasked with replacing a faulty component on the International Space Station. Floating freely in space, the astronaut carefully maneuvers towards the worksite, using handholds and tethers to control their movement. Upon reaching the designated location, the astronaut attaches a tether to a secure point, anchoring themselves to the station and preventing any unintentional drifting. With their position secured, the astronaut can now focus on the task at hand, using specialized tools to remove the faulty component and install its replacement. Throughout the spacewalk, the astronaut remains tethered to the spacecraft, using the tether to maintain their balance, adjust their position, and prevent any uncontrolled movement. The tether acts as an extension of the astronaut's reach, allowing them to move with confidence and precision in the weightless environment. Without tethers, spacewalks would be significantly more challenging and risky, with astronauts constantly battling against the disorienting effects of microgravity. Section 5. Preparing for the unknown, the rigors of astronaut training. Venturing into the unforgiving environment of space demands exceptional physical and mental fortitude, unwavering focus, and the ability to perform complex tasks under immense pressure. Astronauts, the elite few chosen to embark on these extraordinary journeys, undergo years of rigorous training to prepare them for the challenges and dangers of spaceflight, including the intricacies of spacewalks. This comprehensive training program encompasses a wide range of disciplines, from mastering spacecraft systems and conducting scientific experiments to developing the physical and mental resilience required to withstand the demands of space travel. One of the most crucial aspects of astronaut training for spacewalks is acclimating to the disorienting environment of microgravity. To simulate the weightlessness experienced in space, astronauts spend countless hours in NASA's Neutral Buoyancy Laboratory, a massive pool that houses full-scale mock-ups of spacecraft modules and equipment. Submerged in the NBL's depths, astronauts don specialized suits that simulate the weight and bulk of actual spacesuits, allowing them to experience firsthand the challenges of moving and working in a weightless environment. Underwater, astronauts practice a variety of spacewalk-related tasks, including operating tools, handling equipment, and performing routine maintenance on simulated spacecraft components. They learn to control their buoyancy, maneuver with precision, and work effectively in the three-dimensional environment of space. The NBL provides an invaluable training ground for astronauts, allowing them to hone their skills and build confidence in a controlled, simulated environment before venturing out on a real spacewalk. Beyond the physical challenges, astronaut training also focuses on developing the mental discipline and teamwork essential for successful space missions. Astronauts undergo extensive simulations that mimic the stress and isolation of spaceflight. testing their ability to remain calm, focused, and effective under pressure. They learn to work together as a cohesive team, communicating clearly, coordinating their actions, and supporting each other through challenging situations. This comprehensive training program ensures that astronauts are well prepared for the mental and emotional demands of space travel, as well as the technical aspects of their mission.